Good morning, children. Good morning.
Good morning.
Good morning, ma'am.
Good morning. Good morning, children.
Good morning, ma'am.
Good morning.
Good morning, ma'am.
Good morning, children. Did you find time to complete the assignment which I had sent on cubes and cube roots, the last part of the chapter?
Yes, ma'am.
Okay, you were supposed to. I had shared the videos earlier also.
Yes, ma'am.
Yes, I resent the videos yesterday along with the assignment. Okay. I shall post the answers to the assignment after the class. Because you have a video to understand the working. I'm not explaining that now. I'll share the answers. At the end of the session, I'll post it on WhatsApp. So that completes cubes and cube roots. This is our next chapter, understanding quadrilaterals. So let's understand the meaning of these terms. Curve, open curve, closed curve, simple closed curve. Curve, open curve, closed curve. And this closed curve can also be a simple closed curve. A closed curve can also be a simple closed curve. Am I audible, children?
Yes, ma'am.
All right. Now, what is a curve? A figure traced out on a plane surface with the help of a sharp pencil without lifting it is called a curve. You understand that? When you try to draw something on a plane surface with the help of any writing instrument, children, it need not be a pencil. With the help of any writing instrument, maybe a sketch pen or an ink pen, whatever, any writing instrument. So a figure traced out on a plane surface with the help of a sharp pencil without lifting it. You shouldn't lift the pencil. When you start to trace something, you must go on and stop somewhere. You should not lift and continue. If you lift and continue, it is not a curve. I'll tell you again. If you try to draw a figure on a plane surface, that is in your notebook. Okay, you're trying to draw something in your notebook. While drawing, when you start drawing, you should continue and finish your diagram or whatever. You must finish it without lifting the pencil. You must, once you start tracing, you should complete tracing and then only lift the pencil. Such a trace is called a curve, or such a figure is called a curve. So according to the definition, a line segment is also a curve, because how do you draw? Now just take a pencil and try to draw a line segment. Freehand. Take a pencil and try to draw a line segment just to maybe some 5 centimeters. So AB 5 centimeters is a curve. So a curve need not be bent actually. When we say on the road, when we say that there's a curve ahead, that means you understand it's a kind of a U or a C. When we say on the road, when we say there's a curve ahead, curve, C-U-R-V, curve ahead, it's in the form of a C or a U. Curve. A straight road, we don't call a curve. A straight road, we don't call a curve. But in mathematics, since you can draw a line segment, you can start at a point and go on and finish at a point. So a straight line is also a curve in maths. Is also a curve in maths. Open curve. A curve that does not end at the starting point. So you use the pencil and you try to trace something, but the finishing point is not the same as the starting point. Such a curve is called an open curve. That is, you use your pencil on a plane surface, you're tracing a figure. You start at a point, and when you finish the figure, you don't come back to the starting point. Your end point is a different place. So if the starting point and the ending point, they are different, it is an open curve. If you start somewhere and when you finish tracing the figure, if you are at a different point, not at the starting point, then that curve is called an open curve. But if you come back to the starting point, so you start at a place and you come back to the same place at the end of tracing the figure. So when you start at a point, you draw the figure, and at the end of it, you come back to the starting point. You come back to the same point from where you started. It's called a closed curve, which means when the start point is not equal to the end point, when the start point is not equal to the end point, open curve. When the start point is equal to the end point, it's a closed curve. Now, what is a simple closed curve? A closed curve, a simple closed curve must be a closed curve first. A simple closed curve must first be a closed curve. So what is a simple closed curve? A closed curve which does not intersect itself. So that means in a curve, the starting point and the ending point, they are the same because it's a closed curve. So the start and end point are the same. And in such a curve, when it does not intersect itself, when the curve does not intersect itself, you will understand better. I'll show you some figures, you will understand better. Now we'll just grasp the definitions. A closed curve which does not intersect itself, it does not cross over itself. It does not cross over itself. It does not cross over itself. It's called a simple closed curve. A simple closed curve must first be it should be a curve. It should be a closed curve. See, first it should be a curve. There are three terms there: simple, closed, and curve. First, it should be a curve. If it's a curve, then it should be a closed curve. And in the closed curve, if the figure doesn't cross over itself at any point, it's a simple closed curve. If the figure does not cross over or intersect itself anywhere, then it is a simple closed curve. So a curve is basically a figure which you trace on a plane surface with the help of any writing instrument. Need not be a sharp pencil. So when you trace a figure on a plane surface, without lifting your hand meaning without lifting the tip of the pencil, such a figure is called a curve. So the pencil tip should be in contact with the paper. The pencil tip should be in contact with the paper till you finish the figure. You shouldn't lift it. The pencil tip should be in contact with the paper till you finish tracing the figure. If you lift and continue, it is not a curve. Suppose you do something and then you lift and you continue. You lift the pencil and then you continue. That is not a curve. That's not a curve. I slightly lifted and continue. No. You should not lift. At every point, the pencil tip should be in contact with the paper. So that is a curve. Open curve is where the start point is not equal to the end point. Closed curve, start point is equal to the end point. Simple closed curve, a closed curve, that is a curve in which the start point is equal to the end point. If it does not, so if a closed curve, that is where the start point is equal to the end point, if such a curve does not intersect itself or does not cross over itself, it's called a simple closed curve. Got the terms, children?
Yes, ma'am.
All right. We'll come to this slide later. We'll just understand with the help of figures. Now tell me, children. Each one of us should understand. So see here. So maybe the first figure. So I start here. I put my pen. This is the plane surface. I keep my pencil point here and I go like this. See here, I'm drawing. See here, I'm going. I did not lift the pencil. I finish here. Now first tell me, is it a curve? How do you decide? See, whenever you're asked a question, you should go back to the definition. See, it's not like, yeah, it is a curve. No, it's not. It's not like that. Use the definition. What does the definition tell you about a curve? If you can complete the figure without lifting the pencil, it is a curve. So you should ask yourself, did I complete or did she complete the figure without lifting the pencil? If I completed it without lifting the pencil, it is a curve. If I lifted the pen, see now, I may have lifted, but this figure can be drawn without lifting. That's the point. Now you don't say, what if I draw this figure and I lift the pencil in the middle, then is it not a curve? Not like that, children. Okay, please don't ask such questions. So if you say like, I started to draw, then somebody called me, so I had to leave it there and I had to get back and then I continued, then is it a curve? It's not like that. So you can complete this figure without lifting the pencil. That's what it is. So when you start here, you can go like this, and you finish it here. So what's the definition of a curve, children?
A figure traced out on a plane surface without lifting the pencil.
Yeah, without lifting the pencil. So was the first figure, were we able to draw the first figure without lifting the pencil?
Yes, ma'am.
So is it a curve or not?
It's a curve, ma'am.
It's a curve. Now, is the start point equal to the end point?
No, ma'am.
Yeah, where did I start and where did I finish? The start point and the end point. I started somewhere in the middle, but the end point is outside somewhere here. So it's not equal. So is it a closed curve or an open curve?
Open curve, ma'am.
It's an open curve. You can see the terms here. Open curve, closed curve, simple closed curve. Okay, so it is a curve because we were able to draw this without lifting the pencil. And it is an open curve because the start point and the end point, they're different. So it's an open curve. What about this, children? So that's all we can discuss. Now, see, now this is a curve and it's an open curve. Finished. Now we cannot talk about a closed curve for this, but this is done. Meaning we understood it's a curve, and in a curve, more specifically, it is a simple curve. Finished. That's all about this. You can also draw this from outside, children. You can also draw it from outside like this, You can draw it from outside. You can also draw it like this from outside and finish it inside. I'm moving the cursor over the figure. I hope you're noticing that. Children, are you noticing the cursor moving over? Did you notice the cursor move over the figure?
Yes, ma'am.
All right, children. All right. Now tell me the second one, children. You can start from anywhere. See, it's not that you should start from here. You should start from here. You may see, when given this work to different people, each of them might start in a different way. But the question is, can this be traced without lifting the pencil? We have to start from there because that is the basic definition of a curve. So the first thing you should ask yourself is, can this figure be, you start from anywhere, but can it be drawn without lifting the pencil? So say we start here. So we go like this, we go like this. We didn't lift the pencil. We go like this, we go like this, and we finish here. So is it a curve?
Yes, ma'am.
Why is it a curve?
Because it is drawn without lifting the pencil.
Yeah, because we can draw this figure without lifting the pencil. Okay. Is the start point equal to the end point?
No, ma'am.
No.
No, ma'am.
Yeah. So is it a simple curve or a closed curve?
Open curve.
It's an open curve. It's not a closed curve, it's an open curve. So it is a curve and it's an open curve because the start point is not equal to the end point. Look at the next figure. Is it a curve? See, suppose I start from here without lifting the pencil. See, now see, you can draw this like this. You can make the next kind of thing and then join this and this. Maybe you, so just because you draw it like that doesn't mean that it's not a curve. See, if you say I drew this figure like this, I've made this X first and then I joined these two line segments. No, it's not like that. This figure can be drawn without lifting the pencil. If you are drawing it in bits and pieces, doesn't mean it's not a curve. So this figure can be drawn. See, maybe if we start here, you can go like this, then like this, then like this, and like this.
Ma'am, it is
yes.
Curve or closed curve, ma'am.
Is it a curve?
Yes, ma'am. It's a curve.
Yes, ma'am.
Yeah, because we can draw this without lifting the pencil. Is the start point equal to the end point?
Yes, ma'am.
Yes, ma'am.
Yes, you finish where you started. So it is a closed curve. And in the closed curve, you can see that these two line segments, they cross over one another. So it's not a simple closed curve. It's only a closed curve. It's not a simple closed curve. Because if it's a closed curve, you can discuss one more thing. Is it a simple closed curve? When it's a closed curve, we have one more thing to discuss. Is it a simple closed curve? It's not a simple closed curve because you can see that the figure crosses over itself here. See, you go through the same point here. Do we understand? See, when you draw like this, you're crossing over. See, at this point, you're crossing over the figure to finish it like this. You're crossing over. So this figure, it intersects itself. See, the figure goes over itself here at this point. So it is a curve because this figure can be drawn without lifting the pencil. This is a curve. It is a closed curve because the start point is equal to the end point. And because it's a closed curve, we have one more definition to discuss. Is it a simple closed curve? It is not a simple closed curve because you can see in the figure, the figure intersects or crosses over itself. So it is not it is not a simple closed curve. It's only a closed curve. It's not a simple closed curve. Yes, children, next one. Next one. Is it a curve?
Yes, ma'am.
Okay, so it is a curve. Yes, because maybe you start here, you go like this and like this. So yes, it is capable. I'm sorry, we are capable of drawing this figure without lifting the pencil. So this is a curve. Is the start point equal to the end point?
Yes, ma'am.
Yeah. So it is a closed curve because the start point is equal to the end point. It's a closed curve. Is it a simple closed curve?
Yes, ma'am.
Yes. It is a simple closed curve because the figure does not intersect itself anywhere. The figure doesn't cross over like this. It doesn't cross over itself like this. So it is a curve because you can draw this figure. You can draw this figure without lifting the pencil. So it is a curve. It's a closed curve because when you start from here, upon completing tracing this figure, you come back to the starting point. So it is a closed curve because the start point is equal to the end point. It's a closed curve. And it is also a simple closed curve because the figure does not cross over itself anywhere. It doesn't intersect itself anywhere. So it is a simple closed curve. All right, children. So I think by now You're sure about the terms curve, simple curve, closed curve, simple closed curve. Understand?
Ma'am, can you show the previous slide 1 minute, ma'am?
First one?
The example of the curves, ma'am. 1 minute, ma'am.
Yeah. Done?
Ma'am, I have a doubt, ma'am.
Yes, Kirtana?
In the last closed curve, no, ma'am.
Shall I go back to the definition?
No, ma'am, this picture.
Yeah.
In the right side, the last closed curve, right, ma'am?
Let me say 1, 2, 3, 4, 5, 6. Which one are you talking about? We have
Yeah,
discussed 4. 1, 2, 3, 4. Any doubts with 1, 2, 3, 4?
No, ma'am, no, ma'am.
We'll do all this. We'll do all this. I'm just going back to some definitions. Yeah. Now you got the definitions of the terms or the understanding of the terms curve, simple curve, closed curve, simple closed curve. Now, what is a polygon? A simple closed curve made up of only line segments. It should be a curve. It should be a closed curve. It should be a simple closed curve. And it should be made up of only line segments. A simple closed curve made up of only line segments is called a polygon. A simple closed curve made up of only line segments is called a polygon. So you know what a curve is. If you can draw it without lifting the pencil, it's a curve. Closed curve, the start point should be equal to the end point. Simple closed curve, the figure should not cross over itself at any point. Then it's a simple closed figure. Sorry, simple closed curve. Simple closed curve. Now, if the simple closed curve is made up of only line segments, if the simple closed curve is made up of only line segments, then it's called a polygon. Then it's called a polygon. A simple closed curve made up of only line segments is called a polygon. All right. Now, here different types of polygons. Yeah. A polygon with we'll just come back to the slide later, children. So a polygon with 3 sides. These are polygons. These are polygons. A polygon with 3 sides is called a triangle. A polygon with 4 sides, quadrilateral. A polygon with 5 sides, pentagon. 6 sides, hexagon. 7 sides, heptagon or septagon. 8 sides, octagon. 9 sides, nonagon. 10 sides, decagon. And if it has 25 sides, then 25 gun. Just put the value of the number of sides, n gun, n meaning, so if it has 55 sides, 55 gun is a polygon with 55 sides. A polygon with 3 sides is a triangle. A polygon with 4 sides, quadrilateral. A polygon with 5 sides, pentagon. 6 sides, hexagon. 7 sides, heptagon or septagon, SEP, septagon. 8 sides, octagon, like we say octopus. Octopus, it has, are they called 8 tentacles? I'm not sure of the term. An octopus has 8 tentacles, is it? Okay, you must know that better. 9 sides nonagon. 9 sides nonagon. I always clarify this, children. It's not nanogon. It's not nano. Every year, children get confused. They feel this term is misspelled here. It's not nanogon. Nano is different. Nano means very small. You can just look up in the dictionary. The meaning of the term nano means very small. Nano is something which is very small. Nano means very small. So it's not nanogon, it's nonagon. Nonagon. Okay, and decagon. Please get the difference. It is not nanogon. Just in case you're not able to believe, please look for, check it yourself. Because yeah, in the physical class, children normally say, no, it is nanogon, it is nanogon, it is nanogon. So I can't convince, so I say just have a look. There is Wikipedia, there is, there are so many options to clarify. So yeah, it is not nanogon, it is nonagon, decagon. So children, now you should be able to understand this chart. So a curve can be an open curve, it can be a closed curve, or it can be a simple curve, which doesn't cross over itself. Simple meaning it doesn't cross over itself. A curve can be an open curve, closed curve, or a simple curve. And a simple closed curve, what is a simple closed curve? It should be a simple curve and it should be a closed curve. Then it is a simple closed curve. What is a simple closed curve? It should be this one, it should be a simple curve and it should be a closed curve. If a curve is a simple curve and a closed curve, then it is a simple closed curve. What are polygons? A polygon is a simple closed curve made up of only line segments. A polygon is a simple closed curve. A polygon is a simple closed curve made up of only line segments. Yes, I'll just pause for some time so that you are able to look at every term and get the definition in your mind. See, like when you look at the term curve, so you must immediately get it that a curve is something which can be traced without lifting the pencil. So just do that for yourself. I'll give you 5 minutes for that. Look at every term and see if you can recall the definition. Sure, children, can we proceed?
Yes, ma'am.
Okay. So anyways, I just want to confirm this. So let me ask you once again, what is a curve?
A figure traced out on a plane surface without lifting it.
Without lifting the pencil or the writing instrument is called a curve. Correct. Open curve. Start point is equal to or not equal to? I just want
Start
it in simple
point,
words.
ending point.
Start point is equal or not equal?
Not equal, ma'am.
Not equal to the end point. That's an open curve. First, it should be a curve. Only then we can say whether it is an open or a closed curve. If it is not a curve at all, then there's no point of discussing whether it is an open or a closed curve because it's not a curve in the first place. Okay, what about closed curve?
A curve which starts and ends at the same place.
Okay, so start point is equal to end point, closed curve. Simple curve.
Simple closed curve which does not intersect itself, ma'am.
Yeah, it doesn't cross over. Correct. It doesn't go over itself. Is a simple closed curve or a simple curve. Okay, so again down, since we have simple closed curve. Simple closed curve must be a simple curve and it should be a closed curve. If a curve is a simple curve and a closed curve, then it is a simple closed curve.
Excuse me, ma'am.
Yes.
Ma'am, I have some doubt in the assignment, ma'am.
We'll take that up in the next class. Oh yeah, you asked me yesterday, right? Shall we do it during the last 5 minutes of the class, Madhumita? Can you just remind me at that time?
Okay, ma'am.
Yeah. Right. You asked me on WhatsApp yesterday. Yes, Madhumita, we'll do it. Please remind me at the end of the class.
Yes, ma'am.
Yeah. And a polygon is a simple closed curve made up of only line segments. A polygon is a simple closed curve made up of only line segments. All right. Good to go. Now let's continue from the fifth one. We are done with 1, 2, 3, 4. We understood these figures 1, 2, 3, 4. Now tell me the fifth one. Is it a curve?
Yes, ma'am.
Yeah, it is capable of drawing that figure without lifting the pencil. So it's a curve. Is it a closed curve? Is a start point? Will the start point be equal to the end point?
Yes, ma'am.
So it's a closed curve. Is it a simple closed curve? Does it cross over itself anywhere?
No, ma'am. It is a simple closed curve.
It is a simple closed curve. Yeah, it is a curve because we can draw this figure without lifting the pencil. So it is a curve. It's a closed curve because the start point will be equal to the end point. And since it does not intersect itself, it doesn't go over itself, it is a simple closed figure. See, if you start here, you can go like this, like this, like this, and come back to the starting point. So the start point is equal to the end point. So it is a curve, it's a closed curve, it's a simple closed curve because it doesn't cross over itself anywhere. And is it made up of only line segments, children? Is it made up of only line segments? Yeah, it is made up of only line segments. So this one is a simple closed figure. This one is a simple closed figure made up of only line segments. Made up of only line segments. So what do you call this?
Polygon, ma'am.
It's a polygon. It's a polygon. And how many sides does this polygon have?
4 sides, ma'am.
4 sides. So what is the special name that you can give to this polygon?
Quadrilateral.
Quadrilateral.
Yeah, quadrilateral. Quadrilateral. Okay, fine. The next one. So supposing I start here, I can go like this, then like this, then like this, and I can come back to the place I started. I started from here and I came back there. So is it a curve? No, yeah, first, is it a curve?
Yes, ma'am.
Yeah, because we were able to draw this figure without lifting the pencil.
Yes, ma'am.
So see here, I can do it once again for you. See, supposing you start here. So you should go like this. Go like this. like this, like this, and you can finish it here. So we can draw this. See, if I don't know how to draw it without lifting the pencil, then I can't say it's not a curve. That's my ignorance. If I can't draw without lifting the pencil, that is my ignorance. Because just because I cannot draw, I cannot say it's not a curve. I don't know how to draw them. So you can maybe start here. Anywhere, children, you can start from anywhere. Supposing you start here, see like this here. So you have to go like this.
Ma'am, but it's not a simple closed curve, no ma'am, because it intersects, no ma'am.
Yes, yes, Kirtana. Yes, we are coming to that. Yes. So supposing we start like this, so like this, and we finish here. So it is a curve because we can draw this figure without lifting the pencil. It is a closed curve. It is a curve first. It's a curve. Always come from there. It is a curve. And it's a closed curve because the start point is equal to the end point. It's a closed curve. But it is not a simple closed curve because you can see that at these 4 points, the figure goes over itself. See here at this point, it intersects itself. See here. At these 4 points, it crosses over itself. Yeah, so it is not a simple closed curve. It is a closed curve, but not a simple closed curve. What about this, children? Is it a curve? Now let's do it faster. Is this a curve?
Yes, ma'am.
Yeah, so I'll just draw this quickly like this. It is a curve because I can draw this without lifting the pencil. Yeah, it's a curve. Is the start point equal to the end point?
Yes, ma'am.
Yeah, so it's a closed curve. Is it made up of, and does it cross over itself anywhere?
No, ma'am.
It's a simple closed curve. So it's a simple closed curve. And is it made up of only line segments?
Yes, ma'am.
So it's a polygon. How many sides does the polygon have?
Seven sides, ma'am.
7, huh?
Yes, ma'am.
Let's just check it once again.
Ma'am, 8 sides, ma'am.
8 sides, ma'am. Sorry, ma'am. 8 sides.
Yeah, that's okay. No, all of you should agree with 8. 8 sides. So see here. See here. 1, 2, 3, 4, 5, 6, 7, 8. 8 sides. It's an octagon. It has 8 sides. It's an octagon. It's an octagon. It has 8 sides. Now this one, children. The next one. Is it a curve?
Yes, ma'am. It is a
Yeah.
curve.
It's a curve.
You can sketch it without lifting the pencil. You can do this without lifting the pencil like this. Yeah, is the start point equal to the end point?
Yes, ma'am.
Really?
No, ma'am.
No, ma'am.
No. See, like even if I do it like this, if I come like this, this is the start point. This is the end point. Okay, let me do it like this. The start point is different from the end point. Just a minute, children. Just give me a minute. So yeah, so this is a start point. Supposing you start here, this is a start point. You go like this. And you finish here. This is the end point. This is the finish point. So the start point is different from the end point. So what kind of a curve is it? It is a curve, but it is an
Open curve, ma'am.
it's an open curve because the start point is not equal to the end point. It's an open curve. Then this one, can this be drawn without lifting the pencil?
No, ma'am.
So let me just try. See here. Just watch carefully. Like this. Then like this. Then like this. Sorry, just 1 minute. No, I'm not able to move the cursor over it correctly. Yeah, like this. Then like this. Then this way, like this. Then like this. And come back here. So you can draw this without lifting the pencil. At home, you ask your elders when something is important, you know, in our school days, we used to put a star like this. If something is important, you know, a small star beside it, indicating it's very important. So you can draw this. You can draw, see, you can say like this. See, supposing you start here. Okay, like this. All right. Try it. I'll do it again for you if you want. See here, you can start from anywhere. Supposing here. See here, I start from here like this. Then like this. Then come down like this. Then go like this and come back to the starting. All right, children, this is a curve because you can draw this figure. You can draw this figure without lifting the pencil. So it is a curve. Without lifting the pencil, you can draw. Just try it yourself. You can draw this without lifting the pencil. So it is a curve. And is a start point equal to the end point?
Yes, ma'am.
Yeah, it is equal. Just in case you're not able to trace it, try it, children. You can trace this without lifting the pencil. Please try. The start point is equal to the end point. So it is a closed curve. Now, if it is a closed curve, then you have one more question. Is it a simple closed curve? If it's an open curve, you don't have any further question. Curve, open curve, that's it. If it is a curve and a closed curve, then you have one more question. Is it a simple closed curve? Is it a simple closed curve? No, because you can see it crosses over itself at many points. So it's not a simple closed curve. So if it's not a simple closed curve, it cannot be a polygon. If it's not a polygon, must satisfy two things. It should be a simple closed figure and it should be made up of line segments. A polygon should satisfy two things. It should be a simple closed figure or a simple closed curve. And it should be made up of only line segments. All right. Yes, let's do this quickly, children. Tell me, is this a curve? Now I'm not going to give you the details. Now let's just understand what it is. Is it a curve?
Yes, ma'am.
Simple or closed? Sorry, open or closed?
Closed curve, ma'am.
Okay. If it's a closed curve, is it a simple closed curve?
Yes, ma'am.
Yes, ma'am. It is a simple closed curve.
Then is it made up of only line segments?
Yes, ma'am.
Yes,
Then is the
it
polygon?
is polygon.
It is a polygon. How many sides?
5 sides, ma'am.
5 sides. If it has 5 sides, then it is a, what's a special name?
Pentagon, ma'am.
Pentagon. Pentagon. So this is a curve. It is a curve. It is a closed curve. So because it's a closed curve, next question. Is it a simple closed curve? Yes, it is a simple closed curve. Because it's a simple closed curve, next question, is it made up of only line segments? Yes, it is made up of only line segments. So we have a simple closed curve made up of only line segments. Then it is a polygon. It is a curve. It's not that if it's a polygon, then it is not a curve. It's everything. It is a curve. It's a closed curve. It's a simple closed curve. It's made up of line segments. So it is a polygon. Now, supposing you're given this figure and asked, is this a simple closed curve? Yes, you must say, yes, it is a simple closed curve. Don't say it's a polygon. So I said false for, is it a simple closed curve? True, it is a simple closed curve. Furthermore, it is a polygon. It's true for everything. Is this figure a curve? Yes. Is this a curve? Yes. Is it a closed curve? Yes. Is it a simple closed curve? Yes. And is it a polygon? Yes. What about this, children? Is it a curve?
No, ma'am.
Yes, ma'am.
No, I got 2 answers. Yes and no. So I'm like confused. I'm waiting. Settle down with one answer. Yes or no?
Yes, ma'am.
Yes, ma'am.
It is a curve.
Yes, ma'am.
It is a curve, right?
Yes, ma'am.
It is a closed curve, ma'am.
So we are smashing the definitions. We are just smashing out the definitions. We are creating our own. Please think, children, what is a curve? A figure that can be traced on a plain paper with the help of a writing instrument without lifting it. How can you draw this without lifting the pencil? Tell me, how will you draw it without lifting the pencil? Don't say I lifted little, very little. You lifted, that's what it is. How can you draw this without lifting the pencil? Tell me. Don't say you use 2 different pencils. So I did both same time. I didn't lift any of the pencil.
Ma'am, it's not a curve, ma'am.
It is not a curve at all. It is not a curve because you cannot draw this figure without lifting the pencil. You will first do this. Then you have to lift the pencil to do the second one. Or maybe you do the outer one first. You have to lift the pencil to start this one. It is not a curve. This one is not a curve at all because to make this, we need to lift the pencil. But what's the definition of a curve? A figure that is traced on a plane surface without lifting, with the help of a sharp pencil, without lifting it. A figure traced on a plane surface with the help of a sharp pencil without lifting it is a curve. This you have to lift the pencil. It is not a curve. Okay, next one. This one, is it a curve?
Yes, ma'am. It's a curve.
Yes, ma'am.
Start point, end point, equal, not equal?
Equal, ma'am.
So closed. Closed. Is it a simple closed curve?
Yes, ma'am.
Yeah.
Is it made up of line segments?
No, ma'am.
No, ma'am.
So is it a polygon?
No, ma'am.
Yeah, it's not a polygon. So it is a curve. It is a closed curve. It is a simple closed curve, but it is not made up of line segments. So it is a simple closed curve, but not a polygon because it's not made up of line segments. Next one, children. Next one we understand, right? It's a quadrilateral, right? We did one like this earlier. It's a quadrilateral. This also we finished in the earlier slide. One slide earlier we finished this. Yeah, now tell me about this one. Is it a curve?
It is a curve, ma'am.
Open or closed?
Closed curve, ma'am.
Closed, ma'am.
Okay, if it is closed, is it a simple closed curve?
Simple closed curve, ma'am.
Yeah. Is it made up of line segments?
No, ma'am.
No,
No,
ma'am.
ma'am.
It has line segments, but it is not made up of only line segments. It has line segments. This portion, these portions are line segments, but you can see this one is not a line segment. This one is not a line segment. So it is not, it should be made up of only line segments, but this is not made up of only line segments. So it is a simple closed curve, but not a polygon. What about this? Is it a curve?
Yes, ma'am.
Is it a closed curve? Start point is equal to the end point?
Yes, ma'am.
Yes,
Okay.
ma'am.
Yeah, is it a simple closed curve?
Yes, ma'am.
Yes.
Yes, ma'am.
Is it a polygon?
No, ma'am.
No.
Because this one is not a line segment. This one is not a line segment. Okay. Then this one, is it a curve? Can you draw this without lifting the pencil?
No, ma'am.
Yes, ma'am.
Yes, ma'am.
You can draw it without lifting the pencil. See, like you can go like this. No, suppose you start here. I think we can do it without lifting the pencil like this, then come down. Then, yeah, you can draw this without lifting the pencil. You can draw this without lifting the pencil. See here, like this, then come down like this, and any side like this also. Yes, you can draw this without lifting the pencil. So it is a curve. It is a curve because you can draw this without lifting the pencil. Is a start point equal to the end point?
Yes, ma'am.
Yes, ma'am.
Where did I start? Did I come back to the starting point, children?
No, ma'am.
No, ma'am.
No, we didn't. See, we started here. We started here like this. This is the starting point. No, the starting point is here, but I finished here. The start point is not equal to the end point. See here, I'll do it again. Suppose you come from here also. Suppose you start from here. So we started here. So this is the start point, this is the end point. See, you can start from different positions, okay? So it's not, the start and end points are not fixed. You can, maybe you started from here. So the start and end points need not be fixed. Now, but is the start point equal to the end point?
No, ma'am. It is not equal to the end point.
Start point is not equal to the end point. No, you have to start here. You have to start here, go in this direction, or you have to start here and go in this direction. See, suppose you start here, you go in this direction, and then you go like this, and maybe you can go this way and come back here. Or you start from here, this is a start point. And this is the end point. Start point, end point not equal. So it is an open curve. That's it. If it's an open curve, leave the discussion there. It's an open curve, nothing further. Curve and open curve, discussion ends there. If it's a curve and it's a closed curve, discussion continues. Is it a simple closed curve? It's like you're more curious. It's a curve. And if it's a simple curve, sorry. If it's a curve and it's an open curve, it's a curve, it's an open curve. That is, the start point is not equal to the end point. It's an open curve. Then the discussion ends there. You're no more curious about anything else. But if it is a curve and it's a closed curve, the start point is equal to the end point. If it's a curve and it's a closed curve, then the discussion continues. Is it a simple closed curve? If you get the answer yes for a simple closed curve, then is it made up of only line segments? If you get a yes for that, then it's a polygon. So starting from curve ends with polygon. And if it is a polygon, yes, you can continue. If it is a polygon, how many sides? If it is 5-sided, then it's a pentagon, like that. Okay. Are you sure about all the terms, children?
Yes, ma'am.
Yes, ma'am.
All right, let's proceed. This was the first slide. Yeah. Now match the first column with the correct answers in the second column. I'll ask you now, don't give out the answers. You can just have the answers like 1A, 2D, 3C, like that.
Done, ma'am.
All right. Okay, ready, children? So we have a simple closed curve, a closed curve that is not simple, simple curve that is not closed, not a simple curve. Yes. What is it for the first one? Which is the correct answer for the first one?
Simple curve that is not closed, ma'am.
So 1C. Okay, so you're saying 1C. It's a simple curve.
D, ma'am.
Sorry?
D,
D?
ma'am.
D. Not a simple curve. D. Okay. I'm marking 1D. It's not a simple curve, you're saying. It's not a simple curve. Okay, then. Okay, one of you give me all the answers. That will be better. One of you. Now, somebody said 1D. Give me all the answers.
Ma'am? Ma'am?
Yes.
So first one is D, ma'am. Second one is simple curve not closed. Third one is simple closed
No.
curve.
Please
Fourth
help
is,
me like this.
ma'am?
Please help me like this. Just say 1B, 2C, and so on.
1 minute, ma'am.
Yeah.
Ma'am, first one is B, ma'am.
First one is
D.
okay. Now, children, do one thing. Write your answers, and if possible, take a picture and send it on WhatsApp. Let me see that, because B, D all sounds the same to me. Or let me give out the correct answers, and you let me say something, say yes or no for that. You all have your answers with you, right?
Yes, ma'am.
Yeah. Just tell me if I'm right or wrong. 1C, is it right or wrong? 1C.
Yes, ma'am.
Yes, ma'am.
Correct.
Yes, ma'am.
Okay, 1C. Okay, then I say 2D. Correct or wrong? 2D.
Yes, ma'am.
Yes,
Correct, ma'am.
ma'am.
Okay, then I say 3A.
Yes, ma'am.
Yes, ma'am.
Then 4 is
B.
B. 4 is B.
Yes, ma'am.
Right. Anish, please disable your mic.
Ma'am, when can we discuss the assignment
Yeah.
answers?
Yeah, what's the time now?
Ma'am, 7:56.
Yeah, okay, fine. Let's do that. Yes, what's your doubt, Madhumita?
1 minute, ma'am.
Yeah. Let me open that. It's based on the assignment I sent yesterday, is it?
Yes, ma'am.
Oh. All right, children. So that's about, the introduction to this chapter. Let's continue in the next class. Yes. Madhumita, all of you stay back. What she's asking may be useful for everybody. I don't know which one. Let me just open and show you the questions. Is it this paper, Madhumita?
Yes, ma'am.
No, ma'am, it's the other paper.
No, actually, the others don't know. Madhumita has a doubt. She
Both.
wants to get it clarified. 1 second. Yeah, I sent 2 papers. Yes. Let me open the other one. 1 minute.
Ma'am, I also have doubt in yesterday's assignment, ma'am.
Yeah, sure. We'll discuss it. Yeah. Yeah, this one, Madhumita?
Yes, ma'am.
Yes, tell me.
Ma'am, in the ma'am, 1 second.
Yeah, I think you were talking about this one. Yes. You wanted to know how this one becomes 27 by 8,000, right?
Yes, ma'am.
By simplifying. Now 99, first take up the tables of 11. So 11 nines are, all right, 11 nines are 99. So you'll have 9 in the denominator along with 8,000. And when you divide 2673 by 11, you get 243. When you simplify 99 and this number 2673 in
Yes,
the tables
ma'am.
of 11, in the tables of 11, so 11 nines are, you'll get 9 here, and this one becomes 243. And further, when you divide 243 by 9, because you have that 9 in the denominator here, right? So 9 ones are 9, 927 times is 243.
Ma'am, my doubt is,
Yeah.
how does 3,34,125 by 1,000,000 become 2,673 by 8,000?
Simplifying in the tables of 5. See, when
Okay, ma'am.
334125, when you divide ones by 5, what's the number? 334125. When you divide by 5, you get 66825. Then when you again divide by 5, 13365. Again divide by 5, 2673. Simplifying.
Okay, ma'am.
Like, see, yeah, continuous simplification. Divide by 5. Divide the numerator and denominator by 5. Again by 5. Again by 5. Now, it's not that you should stop at this point. You cannot further simplify this. It's not that, okay, why don't we simplify after this? Why do we stop here? Because you cannot divide both of them by the same number. Maybe this is divisible by a number. This is not divisible by that same number. So this is the simplest form. This fraction cannot be simplified any further. You cannot divide the numerator and denominator by any same number. So we leave it like this. It's not that after this you should not simplify. It cannot be simplified further. And then when this 99 comes down for division, you are able to simplify 99 and 2673. You are able to simplify these two numbers. And that's how you get 27 by 8,000. Cancelling.
Okay, ma'am.
Okay. Children, so I have shared only the question paper, right? I haven't shared the answers. Is it that?
Yes, ma'am, you didn't share answers.
Yeah.
Ma'am, also in the second paper, I have doubt in the 7th one and 10th one, ma'am.
Okay, now today, since it's time, let me share the answers. Let me share the answer slides. Please go through that, mark your doubts, and just try asking me on WhatsApp. Maybe I'll do it there. If not, please make sure you ask me the same questions in the next class on Tuesday.
Yes,
One
ma'am.
of the two. In case I don't get back to you on WhatsApp, please make sure you get it clarified in the class on Tuesday. All right. All of you children, all of you, I'll share the answer slides. Please go through any doubts. Let's get the doubts clarified at the beginning of the next session on Tuesday. All right, children. That's it for today's class. Thank you so much.
Thank you, ma'am.
Yeah, please complete all the notes in your classwork. Thank you, children.
Ma'am, can you send the PowerPoint also, ma'am?
No, I allowed you to take pictures now, right? Kirtana, let me show it again if you want to take pictures. Shall I do it again for you?
Okay, ma'am.
I'll show the slides.
Yes, ma'am.
Okay, I'll do that, yeah.